Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.
So I'd like to introduce Yvonne Dietrich. She is a visiting researcher visiting the VIBE group for another 6 weeks, working with me, Andrew Bagel, on the studying One Microsoft. And Yvonne is a professor at IT University of Copenhagen in Denmark. And she does a lot of work in qualitative empirical studies of software development and software engineering. And she has worked in the past at University of Hamburg. She's also been at IIT Madras, IIT Mandi in the last couple of years in India, doing a lot of globally distributed software development studies. And I really, the first time I heard of Yvonne, she had been talking about her dissertation work where she had software developers go to group therapy to learn how to talk to each other properly. And that just seemed so incredibly awesome, and I just want everybody to do that. So everyone's dysfunctional. Everybody could use some therapy. But now we're going to have some, she's going to talk today about some software engineering ecosystem work that she's done in the last year or so, or last couple of years in her job as a professor. So, Yvonne.
Okay. Thank you very much, and thank you for inviting me here. It's a pleasure to meet all the people here at Microsoft Research. And I'm actually, this is a piece of research that has been going on that I would like to present to you today. Has been going on for a while. So, and it's called Software Engineering Beyond the Project. And well, somehow when we talk about software engineering, we all take for granted software engineering takes place in projects. Wouldn't you say so? So that's what we are teaching. That's what we are teaching, what we are planning for, what the methods are attributing. So what is a project? Well, these are a number of definitions. We don't have to go read them. When it burns down, there's a number of characteristics of a project. So a project has a predefined outcome, a goal. Even if it's not exactly specified, there is some idea that there should be a product afterwards. It's normally said to have a beginning and an end. It has limited researchers. There's a limited number of people working at it for a limited time. And it consists of a number of tasks and activities. So that is in the definitions that the software engineering community provides for what a project is. So, but what if that is not the case? What if software development takes place in a different way? And what does that mean for software engineering? So that is what I would like to talk about today. And I will start with some very, very long, old research where I started to get my doubts about our perception of what the discipline is about. Then I will repeat the main part of the talk. We're looking into software products, and that is probably very relevant for Microsoft because Microsoft is working with software products. That's more or less what you're doing. And then, in a way, what does that mean then afterwards for software engineering? What are the questions? If the project is maybe not the main entity of the activities or the main way of organizing the activities we are supporting, what does that then mean for software engineering as a discipline? What are the open questions here? So I will start with some beginning doubts, and that was in the late 90s when I started to do research at Bleking Institute of Technology after my PhD. We were actually starting to work with e-government. And as I came in as a software engineering researcher, I thought, okay, I would like to talk to the engineers and to the designers. So we talked with people from a one-stop shop, and that was in a time where in Sweden the municipality administration got reorganized into so that you have a one-stop shop where citizens go and about 95% of all the issues were taken care for there. And it was in this reorganization that we asked the head of the one-stop shop of a small municipality in southern Sweden, and she said, well, the designers, that's us. And that kind of like took me a bit of a time to understand and to appreciate that statement. Because I thought kind of the designers, that's where the computer scientists, that's the technicians, that's the people who are actually doing the things, the stuff. So, but if you started to look at the development of technology from a use context perspective, you suddenly had the technology was only part of what was there to design. So we started to call these people then local designers. These are the one-stop shop people at Sölvesborg were part of that. So they, on the one hand, they developed software together with different developers they hired and their own IT people. On the other hand, they kind of discussed with the back office people about what is service provision. And of course, by introducing computers into service provision, you have the citizens coming in and you have to negotiate what does it mean to provide municipal services, now partly online. So if you look at that, then you have different things that get designed and you have different foci of the design. And of course, not all the design is about technology in the narrow sense, but it might be technology in use, how we are actually deploying technology to provide better services. How does the services change for that? And one of the things that came about when you look at the software development from this work infrastructure perspective, you had no clear defined projects, but you had a diversity of interlaced practices of design and use. So you had projects where people were developing specialized software. You had products that were customized, configured for the specific context. You had the development of an internet, which was both contents development and technology development, and all that were kind of going on at the same time. So I started I also thought kind of, okay, well, but there's some software engineers. And if you hear municipal administrators talking about software engineering, I've seldom heard people being that derogatory about software engineers as they are. The main providers are actually providing software for the whole government, so they have a whole much bigger picture, and small municipalities are not in their focus. So they were kind of not liked very much. But then I thought kind of like, well, but you must have some people with whom you like to work as software engineers. And they pointed me to a 5-person company selling an off-the-shelf booking system. They had sat in a very strange place, nearly a village from an American perspective, in southern Sweden in the woods. Of these 5 people, actually 2 were developing the basic software. The 2 and 2 others were customizing the software for the specific municipalities, but they have customers all over the place. They have over 300 customers. That means municipalities using their software in southern Sweden, in whole Scandinavia, Finland, Sweden, Denmark, and Norway. So, and we looked at their development practice. And at that point in time, the HR manifesto was not out yet, but so we called this what we saw agile practices. So they themselves, they said, oh, we're doing it, and we know that we are not doing the software engineering way of things, but we are actually getting things done, and we managed to get our report line, the time that we use on report support, we get that down. So we looked at how they actually developed software, and they released 20 They had 20 releases per year. Most of these releases were very small upgrades. About once or twice a year, they had a bigger release where you actually had to change the database. So the database scheme, so they had kind of bigger installation scripts underneath. And that was the first time where I thought kind of like, where's the project? They have been doing that for 10 years at that point in time, 10, 15 years. And they were kind of like continuously supporting the software and continuously releasing the software. They were happy with it. They enjoyed actually new challenges now and then. So they were moving from a very old-fashioned database to an SQL database. They were moving actually with that, they were moving to Java. So it was not high-end technology. They were happy with it. Their customers were happy with it. Their users were happy. So this is somehow a different way of developing software than what I expected to see in this situation. And that was also the first time I studied the practice of the development of a product. And then over the time, I did more empirical research. And I saw the same pattern again and again and again. And that is what I want to talk about today and the implications of that. To define software products, software products are programs that are developed to be used by more than one user and or customer, and often need to be configured and customized for the specific use context. I distinguish between configuration and customization. Configuration is through predefined interfaces, like, for example, the definition of filters for email readers, clients. Customization is when you actually start to mess around with the code. In many cases, you can do both. They are used over an extended span of time, and they are continuously updated to match the evolving needs of a market. So that is our definition for that. These are examples. For example, Microsoft Word is a product. You can actually configure it, permanently change its behavior through a configuration interface. But you also can go down to the programming language, do macros, and exchange the macros. So you can actually develop your own Word. Over the time, I did research with several companies, and I will talk about these 4 products, 4 cases, in more depth. So we'll come back to them again. I'm using a similar figure as for the diversification of the design in the use context, or from the perspective of the use context, to look at these, what we started to call ecosystems. And this one is one of the things that we are talking about. This is Dynamics Nav. At that point in time, they were, a few years before the research, they were acquired by Microsoft. What I'm describing here is the boxes are organizations or companies. The people in there, they are groups of developers or users, so they are stakeholders. The arrows mean a cooperation around the design of some kind. And and here you have multiple organizations. So that's the notation. How I did the research, the thing is that I actually recognized this common pattern after a number of research projects with these software product companies. So we've done a lot of research, mainly together with PhD students, on the individual projects, but they all focused on different areas. So how do you then kind of, you know that there is something, that there's something in common, but how do you actually make that accountable in a scientific way? So I went back and did interviews with the partners and with the people in the companies we did the research with. So it is an interview study. It's based on 3 interviews per company, and it's with open coding, actual coding. That's how I derived the themes that I come to talk about. And it's based on and triangulated with previous ethnographical field work and long-term contact. So one of the companies is actually people that I know for 20 years. They are friends, and they run a company on developing a software product. The triangulating fieldwork is documented in a number of articles. I don't have them put them up for reading now. If you're interested, I can provide the slides, and you can follow up on some of the themes. However, that is the documentation of the underlying empirical work I based the interview study on. So the first product I would like to talk about, and I talk you through that with a bit more detail, because then we are, you will see that makes it also easier than to follow the analysis, because it's pulling out the commonalities between these ecosystems. That is UIQ. UIQ is a daughter of Symbian, the Symbian company. You might know that Symbian OS was founded as to counter Microsoft phone initiatives as a joint venture by Siemens, Motorola, Ericsson. They were founded actually in Blekinge, that is at close to the university I was working at that time, and we did research with them. We did research focusing on interaction design and user experience with the interaction design group in this company. So UIQ was then at some point in time, Symbian was split up into Symbian OS and the UI framework on top of the operating system. So the Symbian OS was moved to London also to have more people, be able to hire more people. But UIQ was stayed in Blekinge. And yeah, what they did a user interface framework. They developed that in parallel with specific applications for the customers that were also the owners of the company. And that is interesting because you all know Nokia was buying out the others and made Symbian and UIQ the software open source, and that killed the company. So you could think about it as an ecosystem, because actually if you change it too much, you might actually destroy it. They developed this their product, their framework. They developed in parallel with applications based on it. They developed that these applications were then branded and kind of further beautified by the customers and owners, and then there's the users there. And you have, on the other hand, you had third-party developers and who also were not so prominent in the as users and customers, and that was maybe one of the errors that the management did here. On the other side, they cooperated tightly with Symbian because the user interface framework was depending on functionality from the operating system. The second here is Navision. Navision is developing an ERP systems. ERP systems traditionally came with their own proprietary database and their own proprietary language and development environment. That is still the case for Navision. At the time of the interview, they were actually slowly moving the technology stack, implementing as the database and the implementation of the proprietary language and the runtime system over to Microsoft technology. For that was in the beginning of the interview. I wasn't really aware of it, but for that they actually had to communicate and drive requirements into the Microsoft organization. And that they didn't discuss very much about it. So for that they were too much pains. These ERP systems, I said that there's these frameworks and proprietary languages, databases, runtime systems. That is done by, also they distinguish between two groups of developers, framework developers and application developers. And the framework developers, they are responsible for this back-end side of it. And they say there's different kinds of developers. There's different types of developers. So these are people who are kind of really interested in compiler construction, performance, very hard technical stuff. Application developers have often a business background, and they know about the domain, and that is the administration of all the data in a company. So the idea of an ERP system is that you run your whole bookkeeping, administration, accounts, human resource through the application. Opposite to other ERP systems, the idea here was not, as the Navision and Acceptor are targeting smaller companies than, for example, SAP, who is the high-end product in the market. And that meant also that they said, okay, we are providing a basic functionality, but they are opened very quickly for partners to not only configure the software, but to actually customize the code. So the ERP systems are shipped together with the development environment for these people to actually program. These customizations can be changes in the business rules, but they can also be so-called verticals. That means they are developing a whole new module. For example, a module for a specific business area. We had one partner, they were developing for a small airplane carrier. They developed a whole module about what is a flight and what are seats and tickets and pilots and attendees. So this means that you do a vertical, so you have changes in the database, you do a piece of program that has some interaction with the base program, and then you do the interface on top of that. And of course, for that, they are communicating very tightly with the customers here. The next thing is also that they were also fun. They are a company doing hydraulic simulation for, that's actually the nicest pictures in my slideshow. What they're doing, they're simulating water flow, and they have one-dimensional, two-dimensional, and three-dimensional simulation engines, and they combine them sometimes. This is Canberra in Australia, and you see kind of a river here, as it's not exactly under the blue line, but so what you do is you're abstracting the topography of a water system. You identify sections for the model. Then you use these sections and you define how the riverbed looks like. You have rainwater runoff system models there. And based on that, then you run simulations, for example, saying, okay, if you have heavy rainfall, how will the water in the river behave? When will it flood? Things like that. So you can also simulate, for example, what happens if a dam breaks. The company is one of 3 or 4 worldwide leading companies in that techniques. They have been doing They have been modeling the Nile system, for example. That's also one of the things I learned. The reason why Egypt has a big military. They are so much depending on the Nile, so they have to be able to protect their water sources. So that is one of the motivations for them. Anyway, wait. Yeah, we have to. Should have doubled that slide. So at the time of the interview, they were reorganizing their organization. Previously, the simulation engines were maintained and developed by departments focusing on certain modeling tasks. So their main business, they regarded consultancy for governments and for other actors about impacts of constructions on the behavior of the water, oceans, on the behavior of oceans or rivers. So they had the engines and the software maintained close to these consultancy groups. They recognized that was not, on the long run, this was not actually a sustainable way for the software part of it. So, and they wanted to sell the software more independently than before. So they started to develop the software in an own unit. But of course, these people in this software development unit, they were tightly interacting with the people using the software for these specific consultancies. On the other hand, they were developing not only that the people here were configuring or kind of defining the simulation models that were run by the systems. They were also, when you found a kind of a simulation element that was not yet supported by the system, these people had all hydraulic engineering educations. They might have had a PhD in applied mathematics, so they all could program. So they actually all added to the code base, which was also an issue because it meant that the code base developed sometimes pretty in a pretty uncontrolled way. So, however, these people in the city, when we kind of did the research with them, they started to develop another set of customers where you had kind of permanent simulation of water systems in order to manage the water system at the same time. So they would actually continuously say, okay, if we have so many rain, then we might actually have a flooding in 2 days in the city. So that means how can we prevent that and how can we work with that ahead of time? So that was the water management solutions where you did not only ship a report to the customer, but you shipped the whole system, operational system to the customer. And of course, there were other users who used the software as well. The last system is a very different system. That is a system administration tool. Here, it is, again, a very small company who on the one hand did system administration for governmental organizations in Germany. So they had their specific customers, and they kind of, in order to do the system administration, they had the need to have a automatic distribution and installation tool for software in a local area network. There are industrial solutions for that. I'm counting on that one of the solutions might actually be produced here. However, they are very expensive. They don't work for small organizations. So they developed, and then they thought, okay, well, kind of let's do it ourselves. So they developed an open source product that they, together with the customer, they further developed that. However, as it was an open source, of course, other people can use it. Here again, we have the basic software, but to run the software, you need installation scripts for specific programs on specific operating systems and specific hardware. And these installation scripts, they were, of course, done by them, but they were also done and shared by the open source community. On the other side, with this tool, they shipped a Unix kernel. So every time the Unix kernel changed, they had to change. And also every time the operating systems changed, they had to change. So one of the big projects was to make this system able to handle Windows Vista, because that obviously worked very differently from the previous Windows versions. So, yes. So now kind of why did I talk you all through these kind of different cases and different examples, and what can we learn about them? One of the main things is that if you look at the series of ecosystems, in none of the ecosystems the development took place in one place. So there was so the final design, the thing that was running here with the user, that was based on one hand, the direct communication with the people installing that system here, but that again was based on some other software, and sometimes the chain here, like in the Navision chain, this was actually much longer, and each of these stages added to the final software. That means you have to think about an interlace system or kind of related system, communicating system of different design constituencies. What happens here with on the use side is, depending on processes and design decisions taken far away from the user. So it's also difficult to influence this. So I'm also into use-oriented design and development of software. So a lot of the usability methods that we are actually teaching, they kind of take for granted that the software engineer then developing the software is in charge of the design. But that might not be the case. In all places, for that reason, one of the things that was identified as most problematic was the communication with the user and with the user community. So, and all the companies did extra work to be in touch with their user organization. So here in Navision, they had big conferences, worldwide conferences, where they invited users, partners, introduced new features, discussed new features with them. Here they had the same thing. They had companies conferences, user conferences, where they also tried to identify new features or new directions to go to. UIQ had their own user group because where they did long-term studies of the usage of certain applications and features in the phone. So with other words, as it is not clear who exactly is the user, and you're not cooperating with the user, you have to. Also, there is a different way of interacting with your user community.
Sorry, can I
Yeah.
clarifying question? When you talk about users in this context, does each group talk about the user one step down the line, like the framework developers, users of the application developers, not the customers? Okay. Like, is it that kind of user, or does everybody realize the end customer who actually pays money is the user?
Everybody is pretty aware that the end customer is the main user, and these are the people who are paying the show. So all of them are kind of getting into this. Here, what comes from a usability point of view here is, so the usability work at this product development has to take that into account, that you're not actually developing for a specific user, but you're developing for a whole group of users. So, and I think that actually Microsoft had the most advanced system in place here, but also UIQ was not that bad. Or they were also very, very good. The other thing is, from a software engineering point of view, you have actually a situation where you have a use before you have a design. So there's people using the software and who are acquainted with the software, who actually know what the software can do for them. So you have also a different level of interaction with the user. You're not developing from scratch. From a product point of view, and that might be more interesting also from a technical side here, you need technologies that supports both the evolution and the deference of the design. So the design is deferred to the use context, and you can say like, okay, well, what does that mean? What we have a lot of technologies that supports kind of the rationalization or generalization of design. We have aspect-oriented development, we have traits, we have model-driven development, things like that. However, all these kind of technologies are focusing normally on having software engineers as users. However, if you do it like that, you don't have necessarily software engineers as users in these ecosystems. You might have software engineers as users, you might have business people as users, you might even have people who have no software education and no technical education as somebody who's actually configuring the software. So with other words, the challenge here is to make these technologies, to lift them up to the user level, to a domain expert level. And yeah, the other thing is that when you kind of combine evolution and the difference of design, and especially if you have to allow the user to change your code, your source code, or the source code of the application, then you get problems with the upgrade, because you have a two-dimensional evolution of the software. So, and that is still an unresolved issue, because the techniques that we have for that, they work when you can anticipate at exactly which kind of places you will have a change. But they don't work when you cannot predict which kind of places will change. A colleague of mine who is into programming languages, in the beginning of some of the research underlying it, he said, well, kind of, we have all solved this. They just have to use our technologies. In the end, 2 years later, he wrote an article together with one of the PhD students detailing how all the technologies from the scientific community fall short in supporting, for example, ERP customizations in this respect. What you also have is the end-user development interface that is here for customization and configuration. That is only one of the technical interfaces between the design constituencies. So also the interface here, for example, between, on one hand, UIQ and Symbian, and upward. So here somehow the interface was an API. This was also an API. So the interfaces between the technical interfaces, they are separating and bridging between different design constituencies. And these interfaces are contested. Because you want to do the development here, sometimes they kind of reported about that they didn't have the resources to develop a specific feature. These guys wanted it, so they developed it themselves because they also are. And at some point in time, they were saying, well, kind of, but anyhow, we have this bit of code here that every time something you change something here, and that is rather frequent, we have to change with it. So this actually should be maintained here. So they shipped code between companies. And they did the same here between UIQ and Symbian. So with other words, these interfaces have to be carefully also maintained over time. A last thing is, as you have this multiple level evaluation on all the companies worked, so you thought kind of they should have a high level of architectural documentation. They didn't. They worked with what we called a walking architecture. That means people who had the architecture in their head and walked around. And they were, and we discussed with them, why don't you just write it down? Why don't you distribute it? Why don't you have a website explaining your architecture? Especially with these big ones where you had a huge number of people developing the software. In the Vision, at that point in time, there were about 200 people developing the software. And they said, well, kind of, if we, as one of the the PhD student working with the architecture in the project, she did an interview with a number of randomly selected. She went to a fair, to the CeBIT in Germany, and kind of talked to people and had a number of different, did interviews there. And what came out of it is that one of the reasons why the architects were reluctant to put down the description of the architecture is that then the developers would use the architecture without consulting them. And that meant that they wouldn't get an update about what were critical aspects in the software. So they used, in a way, somehow, as they used, as we call that in the article, good architectural reasons for bad architectural documentation. You had a question.
Yeah, it's interesting. I was thinking about the way that you talked about the interfaces between each group, in that when we learn in school how to evolve your APIs, you think object-oriented programming, you make a subclass or you make an interface, and then you just add interfaces for extra functionality, but you try not to delete old functionality. But the notion of being able to sort of change the boundary where the functionality is at all, like the API, oh, it's here, well, actually it needs to be pushed further up this way and this one needs to be pushed back. It's almost like web design, in that you have to decide whether to put things in the client, the mid-tier, or the back-end server, and the division sort of changes as your performance characteristics change. And are there sort of established, I guess, I don't want to say formal ways to talk about that kind of architectural evolution, or is it just a negotiation between parties, which is kind of...
Also I haven't encountered any formal way of this kind of negotiation on an architectural level. But in the cases, it was a negotiation. And it is still a negotiation. So with NAV, they had to say, like, okay, does the database, does the SQL database, does it do what we want it to do? Or do we have to do some add-ons? Or are they doing add-ons for us? Or do we keep our proprietary database? So it's in a way, somehow it's not... There's a problem and there's many solutions. That's why you call it design also.
The negotiation route leaves a big problem where the customers don't have, there's much more organizational friction between customers negotiating with Navision and Navision negotiating with the rest of Microsoft. And that at least Navision was owned by Microsoft, so they could at least call them up on the phone and actually find out their email addresses, whereas the customers can't. And so like their power to move the boundary isn't as, they don't have as much power to negotiate.
We kind of, yes and no, but they are negotiating about something else here. They are the this is not a all friendly relation, because in a way somehow these people are earning money by doing special features. So if now Microsoft gets interested in implementing the special feature in their own software, then they are losing business here. So with other words, you have a negotiation of a different kind of a boundary on that side.
I guess this is the corporate purchase.
Yeah, so sometimes actually I think Navision, I don't know whether they did that after they were acquired by Microsoft, but I know it from before that they actually sometimes they bought software from the partners to make it part of their main application. So, and that was also, so it was very interesting when we did the interview series with these people. They kind of also tried to make, that was in the time when they changed the proprietary database to the SQL, and with the SQL database you couldn't do certain things as a partner. So they had the proprietary database had a very smart indexing system, so you could do very quick searches and reports. So they were kind of trying to lobby through us to get back to the proprietary database. So that was so with, what I want to say with it is that these are negotiation points of who is doing what in this context, and the same here somehow. What can an internal IT department do, or a smart super user? And when do you ask a consultant? Consultancies, they are taking, I don't know what the consultants in the US is taking, but I think it's in about 1,000 Danish crowns, which is 150, 160, $200. So it's quite an amount of money also. So there's a competition between these guys. And on the one hand, they have the same kind of interest as Microsoft. On the other hand, they are competing for the users, for the customers here. And they are somehow taking each other's customers, because its introduction of an ERP system is normally related to a high friction in the organization. So after their first implementation, many companies tend to switch their consultants. So there's also kind of, it's not that you cooperate around the design doesn't always mean that you're nice to each other. With other words, when we were discussing this kind of multi-layer development, I think there's also another point that we don't really, in the programming technology, we don't have concepts for this multi-level development. Or, well, we have concepts, but they are often not working for this real-world application contexts. The last one is the process, and that was actually a surprise. It was pretty, I knew that there was kind of this continuous development, but when I started to do the interviews, all of them said, well, yes, we have one of them called it the heartbeat of the product. That is where the new features are released. So, and that was kind of like a steady pace. And that was kind of characteristic for each of the products. So they had a heartbeat of half a year. So every half year they had a new release with new features, things like that. There were also 3 developers working on it, so it was not a big thing, big company. The ERP systems, they had at that point in time a 3-year release cycle. and they were about to bring it down. They tried to bring it down. I think they are down now with 1 year. So, however, whatsoever the characteristic heartbeat of the product was, there was one cycle that was quicker, and that was bug fixing or small features, patches. That was about 1/10 of the time. So if you had a half-year release cycle, then the patches were every week, every 2. When you have 3 years release cycle, the patches, the bug fixes were every 2-3 months. So you had it was kind of like so there were kind of a relationship, but we didn't put numerics on it. So that was, but then there was another cycle which we actually discovered which I discovered in the interviews, and that was because you had these new features, and the features were not anticipated in the beginning. So often the technical design, the architecture did not actually support these features. So over time, the technical design got worse. So in a regular base, they had to renew the technical design. And that was normally across several of the heartbeat releases. So when the vision was replacing the technology stack with Microsoft technologies, they couldn't put just a 3-year release just on changing the technology, because then they wouldn't have been able to sell anything anymore. So what they did is actually they sliced in the transfer to the Microsoft stack over several of the releases. The smallest, the open source, that was every 2 years or every 3-4 years they had to redo, for example, their data structure, because the new operating systems, there were new features, new operating systems. All that was kind of got into the way. Okay. So with other words, also there's different drivers for different development cycles. So they roughly, we had this research on maintenance and categorization of maintenance. They roughly correspond to the 3 maintenance categories: bug fixing, new feature, corrective, complementary, and proactive maintenance. How to organize such a process is contested. So there were a lot of discussion. Microsoft had different organizations depending on the kind of release. When it was a feature-heavy release, they had feature teams. If it was like a back-end heavy release or a front application-heavy release, they put the framework changes in the beginning and then kind of get them out of the way, get them done, and then focus on the application level. UIQ was when they were experimenting with feature teams, module-oriented teams. They were experimenting with splitting maintenance from development. And as I said, UIQ, the simulation software, this company was reorganizing in order to be able to focus more on the software and not so much on the application. So what was one of the points was that you had to keep track in what happened in the other design constituencies, because what happened here in the partner space will tell you something about what is new features here. On the other hand, what happens here at Microsoft will kind of tell you whether you get into problems in the future. So you had to actually keep track with these things. So what are projects done in this context? And you could say a release is a project, but a release is not a project because it's not from scratch. And also it's not as closed. in these companies, what they did organize as projects sometimes was these changes in the technological base. So they had a project going on in parallel to their evolution, restructuring their main data structure or reworking the main data structure. In the simulation software, when they actually moved the kernel, one of the computational kernels from a Fortran program to, I think they used C# in the end. That was kind of the whole restructuring, rework of the kernel. That was a project. So what you have is that the project is kind of a temporary closure that you do to do certain kind of technological, also to have peace and quiet to do a piece of design in a good way. So, but it's by far not the main way of organizing here. So, yeah, that's kind of coming back as summing up the results. There's no single project but an interlace of development activities. Requirements are moving. So even during the release, requirements are moving all the time. They cannot be regarded as fixed, but are subject to multi-level feedback cycles that you do not control as an organization. There is no one process, but a continuous development with several rhythms overlaying each other. So it's more than agile development in that respect. Software is not necessarily developed before it is used. So it's sometimes used before it's developed. That means new solutions have to take social and technical heritage into account. Architectural knowledge and knowledge management needs to support continuous evolution. And that means also if we want to have architects in this context do architectural diagrams, we have to actually support them with keeping up to date with problems in the code base, so they can actually continuing developing their architectural their architecture. And there is no blank slate, never, and that is confirming something that Lucy Sedgman said in another context, that we cannot design as if we come from nowhere. We always have to, in this context specifically, we are always basing our technical design on something that is already there, and we have to take that heritage into account. And that is, what does that now mean for software engineering? Many software engineering methods and tools are based on the notion of a project, and we might have to reconsider that. We need to cope with interlace of heterogeneous development and use activities, and how we actually make use of the possibility of getting feedback about needs and wishes and how things are used in the continuous development cycle. And that means also we should actually start to support design collaboration along the chain of design, not only within a project, but along this chain of design constituencies. From a use side, we have to think about coming from ease of use to ease of design. Most of these applications can be configured by the end user, and end users are willing and able to do that. They need good user interfaces for that, or good designer interfaces for that. And that requires that we actually think about, when we design a software product, we should not think about designing the functionality, but we should think about designing an environment for somebody else to design. And for that, we have academic tools and languages that are solving some of these problems, or providing us with tools for that. However, they need to develop to fit the reality of software product ecosystems. And that means we cannot ask, for example, people at the partners to use formal methods. as formal methods. If we want to have formal methods on that level, we need to make it more usable. And we need also to allow, as we need to get a better understanding of the requirements for such tools and languages, and especially what does it mean to open, to use them to provide end-user development interfaces for non-professional developers. Yes, and that is the last slide, and the question in a way, but Andy and I were doing the last 2 weeks, we're talking to people here in Microsoft and understanding the reorganization, and one of the reiterating things that came about is, well, kind of, when we're deploying things on the cloud, things get different. But what gets different? Well, it's not different that we have users, and it's not different that we have software products that are configured and that we are depending on other products. So, however, it seems one of the things that I would say is a hypothesis that the processes, the development processes, and the deployment processes, that there the notion of the release starts to disappear. That it's going towards continuous deployment. What does that then mean for the cooperation with the other actors in the ecosystem, especially the users? And how can we support this continuous evolution on multiple levels? Because just because I'm kind of changing the operating system does not mean that I change the services based on it, or that I stop changing the services based on it. So we have even more challenging dynamics in these ecosystems. So, thank you.
Comments or questions?
So what's been surprising with this set of interviews that you're doing here on this side?
As one of the things is that if you have this even more challenging dynamics, as it is that operating systems don't take 3 years, but 1 year releases, 1 year rhythms. It becomes much more important, I think, to have an understanding about what are the features somebody else has to deliver so that I can deliver my feature here. So there's in a way I think the tendencies that I described here, and you could say is based on old technology, they get more extreme in that respect. So you have to be much more knowledgeable about what the operating system is doing in order to build a cloud based on it, in order to what the Windows servers are doing in order to base the cloud on it, in order to be able to deploy software based on it. So you so so a lot of things I would say are the same, or I kind of see it again with these kind of the challenge of kind of, you have a requirement, you want to do certain things, but that means that you are depending on somebody else to do certain things, and how to negotiate this. But in a way, somehow, in a more fast-moving environment, this is, in a way, even more important.
Yeah, it seems like dependencies. So what you talk about, what you lay out is a model where everybody's intimately interdependent, and what product program managers and product managers hate is dependencies.
Yeah, but that is one of the things, because that is what we have been taught in the university, that you have your requirements and you fix them, and then you develop your software, and everything else is is a problem or is a defect. You haven't done your requirements right if they change. So that is what we have been fed up with, as what we have been fed to, kind of like that's what our professor said to us. So you have to much more accept that you're in a moving environment and that you cannot have disclosure for the 6 months that your development takes. So you have to actually, instead of having all these techniques and notations to actually box your project, you have to think about how do I communicate? How do I keep track with the users? So and for that we need to develop techniques and tools and concepts, because we don't, as we have a lot of software product developers who are obviously successful, and they all do stuff that we don't teach at the universities. They do user communities, also they run user communities. They run, they have conferences for their users and for their partners. They have, so they have pilot users and work with them. So all these kind of things we don't teach. So we should actually start teaching it. And we should start developing and abstracting concepts and methods for that.
So if software development keeps getting faster, or deployment, your cadence for deployment, you would like to be able to deploy daily. That works for things like Snapchat, which at this point, you know, I'm sure the first version of Snapchat took them all of a week to build, and then they get $4 billion for doing that. Or is it 17? I forget which one they were. But what happens to pieces of technology that are complex, that are hard to build, that you can't build in a week? Like, you know, getting a Windows kernel right, you know, that's taken obviously years. And even just to try to build, like, let's say some new feature into it, even in the open source world where they go faster, is really kind of a challenge. I mean, it's hard to do that. So if you have such a fast cadence, does that mean that you can only have a fast cadence for the simple stuff? And what happens to the complex stuff if your market changes every month and you're not done yet?
Also there is, I don't have an answer. So that's a good question. I think that is one of of course, in a way, when you add people to fasten the project, you also add overhead. So at a certain point of time, adding people doesn't help you. Actually, open source gives an indication about how software engineering could scale, because they managed to scale, they managed to have a lot of developers doing some kind of coordinated things to one piece of software, even if they have a parliament and also they have governance structures, both organizational-wise and tool-wise. So there is some kind of possibility, but it means also if you start from scratch with developing something, there will be somehow an initial investment, and maybe we are lucky that we don't have to develop all operating systems from scratch. And somehow for the devices that we are, the new devices, we actually know how to develop operating systems. So we have kind of experience. We can take that experience and continue based on it. So I don't have an answer. So, but we might look into the open source communities to see how this can be done. The other thing is that you will still, for some more complex software, we will still have, really fundamental changes will take time. As a new concept for operating systems, that might take time.
All right.
Okay.
Great. Thanks very much.
Thank you, and yeah.